There we go. Gonna start in 30 seconds. Okay. Okay, that's probably good. Okay. The IDs of the participants of a race in their finishing order. So I guess I'll say A equals zero times n plus one. This is the place that the person got. Think that's good? I don't see when this wouldn't work. exactly k integers such the product is n. Okay, any split where the maximum difference is minimized. Interesting. I guess you could say for every factor, what's the maximum set of other factors? If you maximized every other factor, what would it be? So for 100, you could say like try 50, and then you'd say, okay, with 2 and 1, the maximum is 2. Or for 44, you could say try 11, and then you'd be left with 4, k equals 2. I mean, k is at least 2. You choose a factor, you're trying to maximize every other factor. So maybe that's like dp. You could have n by k, and that's fine. So you could say for each n given a k, what's the maximum minimum factor that works? Do you have to do a binary search? I feel like... So let's say you had like 44 and 2. I think if you had something like 7 and 2, you would just immediately say this is prime. No, you wouldn't say this is prime. You could just have 7 times 1. K only goes up to 5. I think that's more useful in terms of time complexity. I don't think that like enables any different strategy. Is there a greedy formulation? Can you say like change a 1 to a non-1? I guess you could change the formulation and say, given the prime factorization, multiply together all the elements in order to be as close to one another as possible. think you could just greedily do that. I think you could say, choose a factor of n, and then for every factor of n, which there can't be that many of those, it's got to be something like log n factors. Look at the prime factorization of the remaining element, see what's the largest element you can create. But I think you don't even need to do that. I think you just look at the prime factorization. You'd say 5, 5, 2, 2. You'd say, okay, I have 1, 1. That goes to 5, 1, 5, 5, 10, 5, 10, 10. And then you would just take the max minus the min. I think that works. For z in range square root of n plus 1, while n% z equals 0, but I kind of want it to be 2 comma that, something, 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 if n is greater than 1, res dot append n. Okay. Well, n% z is 0, res dot append z, and over equals z. Should be 17532. Yeah, that looks pretty good. Oh, I'm just returning the array. Okay. I don't see why you wouldn't do this. There's a greedy formulation going on here, where you're saying you have to attribute an 11 to something. I don't know if that works. Yeah. I think if you had like 42, it would start to have problems. This would be 2 times 3 times 7. So it would say assign a 2, assign a 3, assign a 7. So it should be 3 and 14. No, it got it right. Why did it get this right? Oh, because it started with the largest. Okay. I'll give it a couple more minutes to think of a corner case that wouldn't work. And then this should work with ones. So if I had this be like 4, which would be like 7, 3, 2, 1. Yeah. Okay, what would be the proof by contradiction? Yeah, I didn't wind up doing the weekly last night because I was I think I just got home late. Oh, and my friend like flaked on their thing they were gonna go to, so we ended up hanging out later than I thought. Okay, you need to assign. What would be the order that you assign it in? I tanked like 30 minutes on Q2. I'm trying to prove, I'm almost like the amount of time I've already spent trying to think of a contradiction. I could have just submitted and then it would have given that to me. But I'm trying to get better. I feel like greedy proofs, it's one thing to prove correctness for something that you already have intuition about, but it's another thing to like develop the intuition in the first place. And I feel like proving correctness on stuff like this it makes like it makes it a lot more robust for more difficult things where you have trouble like actually coming up with it. That's kind of my read. So I'd rather not just like give myself the answer on a platter of whether this works or not. You greedily assign the smallest thing. So every step of the way, let's see, what this is saying is, I think the proof by induction here would be if there's exactly one factor. Yeah, 3,000 people getting this, especially in the world of ChatGPT, that is not an easy question. This may as well have been like a segment tree question or something. No, it's okay. Already, like what I thought up here is not super obvious. So this does, if I'm really metagaming it for a moment, like this does kind of match my read of 3,000. But I don't know. I found like actually the last multiple contests, like for whatever reason, Q2 is insanely difficult for me and then the other ones aren't, because this one tends to be greedy and then these tend to like rely on some weird algorithm that I happen to know. No, I'm not gonna get distracted. So what's a world where no, I'm gonna follow the line of logic of let's say M equals number of prime factors of n. So in the case where m equals 1, the only thing you can do is say f0, 1, 1, 1, dot, dot, dot. It could only be one more because k can only go up to 5, but whatever. Okay, m equals 2. It has to be f0, f1, and then if there's anything else, let's say just n or k equals 2. This has to be the optimal thing. You assign 1 to each. Okay, m equals 3. And ideally, I'm going to be able to say m equals I, and then m equals I plus 1. And if I can prove this, and I can prove this case, like the base case, then I know that that's like a proof by induction. So for m equals 3, there's no world. There's at least in the case of 2 to 3, there's absolutely no world where you wouldn't say f0, f1 times f2. Because if you sorted these in decreasing order, you know for a fact this will be less than or equal to this, and therefore the difference is minimized when you have this times this versus this times this. So you would always want to do this. Okay. So for m is I, let's say we have fj times fk and so on is greater than or equal to the next thing, which is fl I'm not going to use this terminology. I'm just going to say fj0, fj1. This is going to be fj2 times fj3 is greater than or equal to the next thing, and so on. So in this world, you would always want to assign it to the smallest thing. And then that may well make it be the largest thing. That feels like a pretty trivial proof, like to the point where I'm like, I think I might be missing something. Like I had kind of, this is a straight up distraction, but oh, they have like a little mode. Where is it? Oh, if you click on this, it shows you like all of the different concepts. It's kind of cool. But specifically with, where was it? Rejection sampling. I was pretty proud of this. This question is like, create an algorithm that constructs a random point within a circle. So like, how do you do it, right? Because like the problem is if you just naively, and I think this is what most of the solutions are, is like some optimization on this. If you just naively said, okay, we'll take a random X and a random Y and then see if that point is inside or outside of the circle. And if it's outside, like do the program again. And eventually it's like vanishingly small of a chance that you get here. But that's like not efficient in my mind. So my strategy was to say, okay, we'll take a random distance between 0 and the radius and a random rotation between 0 and 360 degrees and then translate that into the point. But then the problem is, if you think about it, like if you drew all these lines of like all the possible things that you could do as like probability distributions, like this circle in the center is a lot more densely packed with line compared to like out here. There's like not as much line. So in like it's in my mind, this comes to mind because it's like this seems like this would just kind of work, but there's this insidious little detail that makes it not work. Yeah, it's not uniform. I was pretty proud. I was like, okay, well, the area of a circle with twice the radius, like, or with x times the radius, is going to be x squared times the area. So therefore, like the distribution scales exponentially. So therefore, what you really want is to have a random number, a uniform number between 0 and 1, take the square root, and then multiply it by the radius. And then I took it a step further because I was like, the square root is kind of expensive. You can just say like the max of two random numbers between 0 and 1 is the same as the square root of a random number between 0 and 1, which I was pretty proud of coming up with and then implementing this myself. But anyway, that's coming to mind here because I'm like, you got to sleep with one eye open. This may well have some bullshit case, but I've talked about it enough. I might as well. Let's see. Yeah. 180 and 2. Okay, well, here's where it would be. So I guess, what is this? 5 times 2 times 9 times 2. Is that right? 12 and 15. Oh, because 9 is 3 times 3. The less you think about the problem, the closer you are to the solution. Yeah. Except in this case, I guess. It's very close, though. But I think this throws my whole kind of concept in the trash. It's also like, I mean, how many prime factors can a number have? It's like O of log n, right? Something like that. Like natural log of n. So I feel like you could almost just be like, have a base k system and just literally brute force it. Like, what's that worst case? K is 5. The natural log of this is 10. Yeah. No, that wouldn't work. If it was 10 to the 5th, it would work, but this would be 5 to the 10th, which I think is going to be way too big. No, I don't know. It's not that bad. I think that might just be worth testing at the point where it's like a time complexity problem. I feel like you might as well just test that. Is there any world where you backtrack and then you can get it down to like some Catalan numbers time complexity instead of just straight up 5 to the 10th? Okay, well, what's the worst possible case? The worst possible case is that it's something like 2. So yeah, actually, if it was all 2s, you're in for a pretty bad time. Damn. You could say, what index are you at in the number of prime factors that there are, which is going to be probably this. No, probably one more. This is 100,000. So yeah, there can only be, actually, yeah, 1, 2, 3, 4, 5, 6, 7. There can only be 7 distinct prime factors at most for every number. So if there can be 7 distinct prime factors at most for every number, I feel like you could say like, what's dp at I at j, where like I is what index you're at in the prime factors. J is the maximum number you've seen so far. No, you would kind of need one more thing, actually. Okay, well, what is log base 2 of 100,000? 16. Let's say 17. No, it would be 16. So the most prime factors a number can possibly have is 16. So if the most numbers a prime factor can have is 16, I think what I wanted earlier was that. No, I didn't want that. I don't know what I'm thinking of. Yeah, why don't you just say, like, in this case, you could have I is the factor, J is the count of the factor that you're at. I don't even think you need that. I think you just say, like, you would need K as well. No, this wouldn't. No, this could maybe work. Yeah, you say, I'm coming up. Yeah, you do need K, but you say, I'm coming up with a new number. No, I don't. No, this could work, because if you remove a single K, you can say, okay, try if this was the factor that I cared about. But damn, how many factors are there? No, I still think it's logarithmic, so maybe you're still okay. You could say, choose this factor. Try 10, try 5, try 2, try 100. And then you'd say, okay, now I have this like state space where it's like, I'm trying to maximize all of the factors. I'm trying to maximize the minimum of all of the factors. And then you could have a like DP where you say DP at n at 16. Although you could immediately divide this by at least 2, but that's like a small detail. Okay, I think I'm going to come back to this one. Task is find 2 distinct indices, I and j, such the product of nums at I times nums at j is maximized, and find the binary representations of nums at I and nums at j do not share any common set bits. That doesn't seem that bad, right? I think you just need to be, you need like a binary try or something. You need to be smart about like how you do that. Yeah, I think you could say, take X. Let's say X is like that. Well, that's a bunch of like that. And then you could say, okay, exactly reverse it. And then any number that is entirely within these set bits, you can use. How do you get that quickly? I think you just use a try. right? Did I solve? No, I didn't. I came up with a solution that I'm going to try. The solution is basically take the first factor that you're saying, nominate this to be the maximum factor. So try that. And then just go through the log n factors that there are. I think, right? I think there's log n factors. I don't know. And then, well, are there log n factors? Let's see. If you had 2 times 3 times 5 times 7 times 11 times 13 times 17. I guess the most factors you can have is 6. So in this world, you'd say there's 2 to the 6th different non-prime factors. Like if you just bit masked this. So 64. So you could say that's relatively close to constant. It's like not otherworldly. And then you would say, okay, now you have some sort of state space that's like k minus 1 times n over at least 2. And then you just say, okay, well, like I nominated the maximum. Now I'm trying to maximize the minimum, which really feels like a binary search thing. But I think you could just use DP, where you have DP at I is the current minimum, at j is the number of remaining, at k is the index that you're in the array of all of the prime factors. Which, worst case, I guess would probably be this, because you'd have 64 different state spaces that you'd have to try. And then of those state spaces, you would have k would be 4. This number would be 6. So that's up to 24 state space. And then I guess the largest of these would be something like 10 to the 5th over 2. So basically 10 to the 5th. I think that would be really, I think it would be really close, but it would probably be too much, at least in Python. Because you'd say like 10 to the 5th times 24 for this whole state space times 64. It wouldn't really be, because any other factor that you're dividing would quickly like grow to be very large, and then this state space would be much smaller. But that sounds like a nightmare to implement. So it's either going to require me to do it iteratively, or it's not going to work. So I'd rather just think about it and move on. So with this, I'm thinking you need to get every number. I'm guessing, yeah, 10 to the 5th. Are they distinct? No, it doesn't really matter if they're distinct. Well, are they always positive? Yeah, they are. So you want like necessarily the largest binary representation of a number that you can get. So yeah, I don't see, no. It's trickier than this, because this could be a 1 or a 0. It doesn't really matter. You just need something that's entirely enveloped by this number. This is sponsored. I'm guessing it. I guess it makes sense that it's pretty tough. 163, damn. Maybe there's some sort of divide and conquer approach, like over the ones and zeros. No, that doesn't make sense. That requires like contiguity. guess it can only really be a few things in terms of like what the time complexity is. So it's either going to be something like O of n times O of 1, where you're immediately able to say like, okay, I'm at a 5. I just instantly know from before this, or O of n times O of log x, something like that. You're at this 5, and actually I guess I'll write both of these down. It's probably not O of 1. That seems unlikely. You at least have to check all the bits of the number that you're in. Yeah, what if, I feel like you could almost have like a segment tree kind of structure where you would say when you traverse into this 1, you're also, it would almost be like a suffix tree adjacent thing where you're traversing into this 1, but then you're also traversing into the 0 at this spot. So you get a 0 and a 1, and then another 0 and 1. And you'd say, okay, but then this also goes to those. So that means like if you're traversing down through, it doesn't really matter whether you went to a 0 or a 1 here. You're just looking for the largest number that's encapsulated by anything here. Or maybe you could say the inclusion of a bit is a monotonic operation. Therefore, there could be a way to sort this so that you know at any given moment, like a bit is like everything before this didn't include the bit, or everything before this did include the bit, or something like that. And then that makes the process easier. Because it's like, if you have a number, let's say you have like that, the inverse of this is going to be 0, 1, 0, 0, 0, 1, 1, 0, 1. And then you just want any number that's encapsulated within this. It's not really a way to take a range and, is there? Is there? Could you have a structure where you could query where you plug this number in and it gives you some question mark number? You're really looking for the largest. Man, this is rough. I thought I was doing well at these virtuals. So a naive try wouldn't really work. Maybe there's something more to the order of parsing. I guess you could say if you invert the numbers. I think one thing you could immediately say is like, no. Interesting, nums at I only goes up to 10 to the 6th. So that log 2 is 20. That feels like a pretty purposeful choice. That log 2 is 20. 20 times n could work. It almost makes me wonder if what you would almost want to do is like set up a sieve. If you set up a sieve, you would say like, could you have some sort of like smart segment tree process where you say like, okay, only take numbers like in these specific indices, take the maximum only of numbers in these indices? That'd be really weird though. You wouldn't have an L and an R. You'd have like a number that you give it, and then the binary representation would like read into that. Okay, well, what if what you did was you said for every number. Yeah, okay. I think this is what you could do. You could set up a sieve. You could say for every number x, x is going to be, let's say, like 1, 0, 1, 1, 0, 0, 1, 0, 1, 1. And then you could say, okay, there's really 1, 2, 3, 4, 5, 6 numbers that I care about. There's 0, 0, 1, 1, 0, 0, 1, 0, 1, 1. There's 1, 0, 0, 1, 1, blah, 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 blah. There's 6 of these. And then you would say, okay, kind of the recurrence relation is that this is going to be the maximum of all of these as far as numbers that actually exist. And then if this number actually exists in the array, then you take this. And then you would say for every number y, take the inversion of that and then look at the maximum and go to that. Okay, that's what it is. Okay, I'll say MA is max nums. And I'm calling this A. M is going to be 1 while M is less than MA. M goes up by 1. Okay, sieve equals, the largest is 0. It looks like if you can't do it, you just return 0. Times, I'll call this lim instead of M. Makes a little more sense. Okay, just make it distinct, because otherwise what's the point? For x in A, sieve at x equals x. Okay, for I in range, lim. For bit in range, I'll just say bit equals 1 while bit is less than or equal to I. J equals I XOR bit. Sieve at I is max sieve at I, sieve at J. Okay, for x in A, equals X XOR mask. MSF res equals max res X times sieve at Y. Oh, oops. If I and bit is equal to 0, continue. Only take bits you can. J is I XOR bit. Okay, that looks pretty good. Oh, oops. Okay, the mask is too big. While lim is less than max. Okay. Oh wait, I don't want 1 to the lim minus 1. I think I just want lim minus 1. One goes to 6, that's right. Mask is 7. Lim is 9, that's right. Length of sieve is 9. 6, 5, 4, 3, 2, 1, 0. Okay, what exactly is the problem? Oh, it's got to be for another test case. 3, 2, 1. I see. So if it's exactly 64, then I guess that just needs to be less than or equal to. Yeah, that seems right. So it's saying 64, 63, 12, 0, 2048. Oops. Hey. Damn, really? Mm-hmm. I am certain that this would pass in C++. I guess so. That's what this lambda is, but maybe even the lambda itself. Okay. Landed that C# job? No. Okay, well that did reduce it by 700 milliseconds. I mean, maybe. Or that's the random variance. Yeah. What happened? I went in. I think I actually did quite well in the interview. It was like weird because it wasn't really a tech interview at all. Like the lady that interviewed me, it was like this was like a real estate job, and the lady that interviewed me like didn't really know tech. 17 seconds. Well, I'll take it. Okay, on to the hard one. But they told you it's a C# job. It was. It's just like she wasn't the CTO, she was the CEO. So I talked to her and I felt like we got along really well. But also I think I kind of swung and missed because like I realized in the background, like she had like a huge TV in her office that was literally just playing Fox News. And I'm kind of a hippie. I think Fox News is kind of an evil company. So that kind of was a turnoff, but I mean, whatever. But she kind of, it was one of those like nobody wants to work anymore like kind of people where it was like just a little weird. And it's like, okay, well, that's fine. Like you're an employer, you're not like my best friend, so whatever. But there were a couple of points where I was like, yeah, like I have done stuff with like renewables and stuff like that. And she seemed to like really not like that. You know how some people just like hate windmills and hate like solar panels and stuff. So I think that was like one thing that was a swing and a miss, but I actually think I charmed her pretty hard. I think that we got along really well, but ultimately I think like she didn't seem really to understand that my resume was like basically had no C# experience whatsoever. And I imagine she was like, yeah, I'll talk to the CFO and like, or the CTO and like, we'll reach out like if it's a good fit. And I think she probably talked to the CTO and the CTO was like, okay, well, this guy seems great, but he just like doesn't know C# based on his resume. That would be my guess of what happened there. But I'm not, it was a nice experience. I think that's like kind of the best case possible as far as like just dipping my toes in the water, but I didn't really expect much of it. I found the question 3 very hard because for me, I would not be able to do better than 3 to the 20. Interesting. I was pretty proud of that sieve solution I just pulled out of my ass. For every positive integer g, we define the beauty of g as the product of g and the number of strictly increasing subsequences of nums whose greatest common divisor is exactly g. What the fuck? Whose greatest common divisor is exactly g. Okay. Seems like some weird logarithmic sliding window thing. Return the sum of beauty values for all positive integers g. Because GCD is like a strictly decreasing operation. Or not strictly decreasing. It's a non-increasing operation. So therefore I'm kind of like, I feel like if you went through, you did the, whatever the name of that algorithm is, where you like take the longest increasing subsequence and then you ran a, yeah, you could say what's the longest increasing subsequence ending exactly at this element. You do that for all elements. You find exactly the greatest common divisor. Maybe there's like some sort of fractional cascading thing you can do to kind of like shorten that. I don't think that would really work, but to like not have to sliding window through your longest increasing subsequence array every single time. Return the sum of beauty values for all positive integers g. Oops. For every, oh wait, what is this even saying? For all positive integers g. Okay, no, that's confusing. Beauty values, the number of strictly increasing subsequences of nums. Okay. So, I mean, how many strictly increasing subsequences of nums can there really be? There can be 2 to the n, because you could have the entire thing is strictly increasing, and therefore every single subsequence you could take is strictly increasing. It's only 10 to the 4th. Nums.I is weirdly 7 times 10 to the 4th. That seems very odd. That makes me think, like, not all hope is lost here. I don't think I'm going to get this in 30 minutes, but I think just like Solaris, I have spent way too long on question 2. Exactly k positive integers such that the product of those integers is equal to n. You're trying to maximize the minimum. Well, multiplication is like a monotonic operation if they're all positive. So maybe you could binary search. Maybe it really is just that. I mean, if it's saying the maximum minimum, like that feels kind of like a tell, but you could say like, okay, just take a random factor and then binary search for whether you can be above a certain number. Take the largest number that you can't be above for the rest of the factors, the rest of the k-1 elements. So for example, for this, you could say like, okay, try 5. And then you could say, okay, well, like the largest number you can get the largest minimum you could get would be 5. Is that how you'd want to do that? That's kind of weird. I think you would immediately say the largest number is going to be above 5, so you don't really want to do that. I mean, is there any way to like not even choose it for a given maximum? Yeah. I don't think you need to have a maximum. I think you just say what's the maximum minimum, because that will naturally minimize your maximum as well. So what's the maximum minimum? You're going to say, I have like this pool of remaining prime factors. Combine them to be the smallest prime factor above the threshold for every number. And then I think you could do that very quickly because there can't be that many prime factors. No. No, because you could have 22s. Right? Or 19 twos. No, it wouldn't be that. It would be like 17. But still, you could have 17 twos. And then you'd say, okay, well, try every single combination of these twos. You could have it be a combination of counts, but that would get really ugly really quickly. Man. Man, I thought the greedy thing was so clever, and it was just straight up wrong. Well, no, I don't know. You might be able to do this. Because if it's 2 to the n, where n is the number of factors, at most there's going to be log base 2 of n. So that means the amount of time to test each factor is just going to be O of n. If you're binary searching it, and also you're just doing that for every k, I think you're kind of fine. So I think that's probably it, actually. It's going to be bisect left, I guess. Well, this isn't really the end of the story. This is the maximum minimum. And then I guess you would just say get everything above that minimum. So it could be 1 up to n plus 1. So you're saying, is it possible to get everything above this? And I think what I'm going to do is return 0 if it's not possible, and the maximum number if it is. For I in range k, factors is factorize n. Scene is equal to 0. Shit. Is this going to be 3 to the n? I don't think so. But I can optimize this. I can do like a 3 to the n trick to make it be like some weird time complexity. Because I don't need to check every single bit mask for every single well, does this make any sense? Yeah, I only need to check the complementary bit masks to scene. So lim equals 1 to the k minus 1. That's all the possibilities. No, not 1 to the k, 1 to the m. For I in range k, mask equals scene XOR lim, while mask I think I'll say while mask 1 something something mask 1 equals mask 1 minus 1 and mask. So now this is going to go down and be complementary. So this is every complementary bit mask to scene. For bit in range m, okay. MSF is infinity -1. That's fine. This is going to be the minimum bit mask greater than the threshold. So A at I is equal to MSF at 0, Scene XOR equals MSF at 1. Forbidden range M if bit and mask 1 equals 0. Continue. Cur times equals factors at bit. So it's saying this is included in your mask, multiply by this. If cur is greater than threshold, if it's greater than or equal to the threshold, you're saying set the minimum to be at least this. Okay. MSF equals min MSF and cur mask 1. Okay, perfect. So then you will assemble some sort of list of factors for every threshold and then return the maximum. What is going on here? Bisect left, so the first thing that's greater than or equal to 1. What's the world where that doesn't happen? The world where that doesn't happen is if the min of A is 1. So I think what I'll do is I'll say, okay, A is 0. If you're able to find a number above the threshold, at or above the threshold, set A at I to be that. Or else, if there's a 0, that means you weren't able to set something. And the world where you didn't change anything and like N is just 1, which I don't think it can be, but is if everything was 1. So then you'd say the threshold was 1. Yeah. Int and float. MSF at 1. Cur and mask 1. Why on earth is mask 1 a float? Probably because it's infinity. So right here I could say if MSF at 1 equals infinity, return 0. It didn't work. Okay, negative 42. Very weird. So check is just returning 0 for everything. So it's saying return 0, return 0, return 0. Everything's returning 0. So res will just be the number that you inputted. This is always returning 0. If I do that, is it any better? No. Okay, so it said the threshold is 23. It's probably backwards. That would be my guess, which is a little bit frustrating. So the threshold is 23. You've seen nothing, you're at index 0. The best you can do is 44, which is true. So it seemed to have gotten that. And then everything after that will just be more of the same. This one is saying 22, 42. Okay. So it's probably that this is backwards. It's that if this returns 0, it's saying it's not possible, and then it's trying to raise the minimum. So I think I'm going to get rid of the bisect left thing because it's going to be confusing. Or maybe not. Maybe I'll say n0 minus 1. But then it's going to be the insertion order in this backwards range. So then I would need to say something like n minus bisect left. So the largest threshold at or above 21 is 21. Okay, so 21 doesn't work. It should go down and down. And then eventually like print something, but it never does. Threshold seen IMSF. So here it said you tried 14 to get above 10. That works. Now you're at I equals 1. K is 4. So eventually it should try 1. Well, what is this? This is 3 times 2 times 7. So yeah, if k equals 4, you're going to have to test 1. 1 is going to be the ultimate answer. Seen is 2. Seen is 3. I think I'll just say a 1 here. Factors is factorize n. M is length factors. Let's get that. And then I'll just say if m is less, if k is greater than m, return 1. That means that you will have to have a 1. Nothing will ever work. (44) and 3, it's saying 9, which seems not right. No, maybe that's right. 2, 2, 11. Yeah, that's right. Okay. So I don't really want to return the maximum of A. I kind of just want to return A. Well, something that's greater than or equal to, I guess, an empty array. Kind of confusing, but whatever. Okay, 1, 2, 2, 11, 12, 15. Fuck. 3, 3, 4, 5. 3, 4, 5, 6. 3, 3, 4, 5. What happened there? So there's an extra 3. No, there's an extra 2 I just didn't account for. Yeah. 2, 2, 2, 3, 3, 5. 3, 3, 4, 5. is seen 59. So it's missing a 4, which means it's missing this. So it's missing a 2. What does that mean? You found the correct minimum, and now it's about... God damn, that's confusing. Okay. Now it's about minimizing the maximum. You know that you'll always be able to greedily multiply by the minimum, and there will be more minima than there is the extra elements that you have. So I guess I can say heapify A for bit in range M if 1 to the bit and seen is equal to 0. That means that you haven't used this. So heap pop A, heap push A, x times factors at bit. Goddamn. 3, 5, 4, 6. 12, 15, 2, 2, 11, 1. No, wait, 1 is not. That's not what should be happening here. What happens if I just get rid of that? Does it freak out? 2, 3, 7. No, it gives the right answer. So what's it doing? It's saying the best you can do is probably 1. Yeah. So therefore, try putting in 1. If you put in 1, you just like assign every number greedily, and then it's fine. Man. Two, 3, and 3. K is 5. Res is 1. So what's happening? It's saying you can't even make 1 work. So I think I'll say return factors plus 1 times K minus M. Oops. $48. So that's 2 times 2 times 2 times 2 times 3. Man, fuck that. Oh my god. This whole thing doesn't work. For real? Oh my god. Damn. God damn. Well, I went way too shallow in the rabbit hole to start, and then I just went off the deep end. So you can't maximize the minimum. DP doesn't seem to work. It doesn't seem like it's greedy. It just seemed like when I formulated the state space, it was like way too big. It was like 10 to the 8th. I was like, there's no way. And you can't not keep track of K. You can't not keep track of N. You can't not keep track of like what prime factors you've used. And between those alone, like 10 to the 5th times 5 times like the number of prime factors could be up to 17. That's already 10 to the 7th. I mean, maybe it's just that and there was a way to leave it at that. Man, well, there goes my streak of good virtuals. Jesus Christ. Even that, though, like, what do you do with that? Do you say dp at I at j at k returns the maximum and the minimum that you could get from this? And then you try to take the lowest maximum with the highest minimum? I don't think it works that way. I don't think you can do that. This is the question they give us in the interview. Oh my god, yeah. Is it just like backtracking? That doesn't sound right at all. Because how many factors could you have? 17 total. So if you just said, okay, like each of those factors goes into one of 5 things, that's like way too big. And maybe you could optimize that because it's 17 if you include just only powers of 2. But if you didn't just include only powers of 2, then there can only be 6 unique factors. And like 5 to the 6th should be fine. But I don't think it's that simple because then how do you reconcile like the same factor? K is small. Yeah, I see that. I mean, I'm like already thinking of like K to the blank, you know? Okay, what if you said, I'm so irritated right now that this whole thing didn't work. The whole point of this was to like escape the like greedy trap because the greedy formulation doesn't work, and then this just straight up fell into the exact same greedy trap. So that was like a complete waste of 40 minutes. More than that, I think. Okay, almost a full hour has gone to this exact problem. Okay, well, what if what you said was for every factor? No, that doesn't. Because sometimes you want to multiply like the same thing by the same factor. Sometimes you don't. K is small. Okay, what would you do if you just did the... What if it was just the worst possible backtracking? You could say, for every single k index, take a bit mask of every single factor, add it in. I bet it's just that. I bet you just you just brute force it and you try every single thing with a bit mask times k. For I in range k, mask 1 equals scene XOR lim. Lim is equal to 1 to the m minus 1. So it's going to be something like the number of factors there are to the fifth. Or no. It's going to be, yeah. No, this doesn't make any sense. I guess you're always looking for the most evenly balanced array. So maybe you say like dp at I at mask is like you do Code Chef. When I watch Solaris' stream, I'll do Code Chef sometimes along with him. Yeah, I don't think backtracking makes any sense. So if you had dp at I at j, and you're saying from the jth index on, from the ith index on, with this mask already seen, what is the most even distribution you can have? Now that I think about it, the complexity is not easy to compute. I think that's a serious weakness for me in these Leetcode contests. I remember there was one like 2 years ago where it was the most confusing possible thing. It was like a binary trie, but every single layer of the binary trie, you would like backtrack through every element that had a one set bit there. And it was like the most, it was like people were like, I don't know what the time complexity is. You just had to like try it. And like, if that's ever the answer, I just don't get it. Cause I'm like, if I don't know what the time complexity is, I kind of just assume it doesn't work. I assumed the number of possibilities would not be so big. Is it some bullshit where like your state space has tuples? I guess that collapses it down pretty significantly. If you said, what's the count of each factor that you have? That's the way to do this. That's the way to reconcile the fact that there's only 6 distinct prime factors you can have, and yet there's 17 total prime factors you can have. Bitmask DP on a tree. You can't just fully brute force it. You can't just say apply every mask to every element. That like doesn't work. Yeah. And I don't even think it would be that. I think it would be something like 5 to the n. Log in elements in the prime decomposition. If you write each element every time it appears, then 5 colors for them. If you write each element every time it appears, then 5 colors for them. It's just there's multiple counts of each element, so I feel like where your thought process that you're explaining is going is like to keep track of that, and then at that point, like the time complexity kind of is off the deep end for me. Like I don't know what the time complexity of that is, because then you're not saying like dp at I at mask or something. You're saying like dp at I at 1,3. Or, 2,3, 7,2. Like, it's something really weird. That feels like where you're going with that. I mean, unless I'm missing something that's more basic. Because I understand that, like, there's 6 total elements you could have, kind of. Well, okay, if you go with the 17 figure, you don't try and optimize that. I mean, it seems like probably the thing to do is get it to 17 to the 5th instead of 5 to the 17th, right? So what would that mean? That would mean if you did 17 to the 5th, you'd say... Yeah, I don't know about that. Because... "17 to the 5th means you're making 5 choices, and every one of those choices is one of 17 things, which just like won't work, right? Like if you have all 2s, then I guess it doesn't really matter, but even then it wouldn't really make any sense because you're not choosing any individual prime factor, you're choosing a bit mask of 2 to the n prime factors, where n is like the number of prime factors you're choosing. So the only thing I can think to do to optimize that is to say, okay, well, if there's multiple of the same prime factor, then record that as a count rather than like 2 to the x. If there's like x of the same prime factor, if there's 10 of the same prime factor, then you can have that be like a factor of 10. Like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's like the only addition to the state space as opposed to 1,000. I guess my mind gets pretty confused when it's like, what happens when you have like 2 to the 5th, 3 squared, 7 squared, like 5 to the 3rd. Like I feel like when you get into that, I'm like, it's really hard for me to visualize what the time complexity of that is. Because I understand it when it's just like 2 times 3 times 5 times 7 times 11 times 13 times 17. Like this makes sense to me. If you bit mask this, there's only so many prime factors you can have. But the moment you have like that, right? And you can account for this specific corner case if you wanted to. But what happens when it's like a bunch of repeated things? Then it's like a mix between these two. Because 2 to the 17 to the 5 and like this are like too different for me. I guess I'm spinning my wheels overthinking this one. Do you have the that Codeforces contest, Solaris? You said it was the most recent Div 2. So it sounds like I'm overthinking it. Yeah, I'm kind of confused. Like log n elements in the prime composition, if you write each element every time it appears, then 5 colors for them. Like I feel like what you're implying is it's like, okay, let's say you have like, these are all the elements that appear, right? And then each one of these is like to the 5th. Like that's way too big. I was saying I have an upper bound which is easy to compute but too big. Yeah, but that's an overestimation. I mean, is it an overestimation? What if you literally had this? If you just plugged in an algorithm that was like, just try distributing every color to everything. Complexity of n and k is the sum of the complexity of d and k minus 1 for d divisor of n. And complexity n and 1 equals 1 for any n. Now to work that out, I guess you can use dp just to compute what the complexity is. It would be too slow. Yeah, I think it would be too slow, right? It would be like... So you're saying compute an upper bound, and then from this, there's another unrelated solution that at least is better than this. But I guess that's the part I'm really having trouble with. Because if you plug this in, you'd be like, okay, 5 times 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 5. You're already like way above it. Yeah, I meant there's an easy way to compute the upper bound. 5 to the log n, but there's a formula to compute the exact complexity. Oh, you're just saying in terms of talking about these solutions that are too slow. I thought that was like a hint towards the actual solution, so I was like, oh, okay, I'll like think about that. Man, feels bad. I mean, I guess you could say if there's more than 5 of the same factor, you just multiply everything by that. That's not even true, though. You wouldn't even want to do that. Like, if there's like 3 2s, you wouldn't just say, like, okay, so multiply everything by 2. I guess the induction rules kind of give it away. I think you're going to have to spell it out for me because I have no idea. Sum of complexities d and k minus 1 for d divisor of n, and complexity n and 1 is equal to 1. So it's literally just this. Okay. Are you is it so it's literally just go through every factor and see where it goes? Like what I had. Are you still doing it with primes? I guess so. So you're saying take every factor, set it to be a at I. You're going to get the number of factors to the fifth. And you're saying the number of distinct factors is small enough that it's like just kind of works out. All right, I'll try that, I guess. Okay, for every factor, n to the 5/3 is also an upper bound. In practice, it's smaller. Where does the 3 come from? You know then n has on the order of n to the 1/3 factors. I didn't know that. That's good to know. So what's n to the 1/3 of... What's 100,000 to the 1/3? Is like 300, I want to say. No, not 300. $50. Okay, I was way off. It's like 10 to the 18. The number of divisors are on the order of the cubed root of the number, even though you need a square root loop to know them. Okay, that's interesting. Man, I guess I didn't know that one. This felt much harder than Q3. Q3, what was Q3? Yeah, this felt much, much easier. It was like not obvious what to do, but... I just like, if I'm weighing kind of the obscurity of knowledge, kind of the concept here to use a sieve in DP, especially seeing 10 to the 6th here, like this is an instant hint that you probably want to have some sort of linear time complexity with that. This feels like a very, I mean, it's an obscure thing, like for sure, but this feels like a very not obscure thing compared to knowing the time complexity of the number of distinct factors of a number. That feels like very obscure to me. Right? Like I feel like I've dealt with more merge sort trees than this, like by like multiple times. Yeah, and also like what is that, 50? That also seems like that's like I wouldn't even consider that, and I didn't consider that because the time complexity seems like really out of whack. Like wasn't there just recently a contest where 10 to the 7th was like not good enough for the Q4? I guess so. Man. Yeah, I didn't even consider this. This seems insane, right? When have you ever looked at 2e8 and been like, oh yeah, of course it's that? There's a lot of trimming. I mean, how can you prove that the worst case example isn't this, though? Well, I went into this question saying it's good to provably know things and not use empiricism. I feel like this was like the exact wrong question to do that with. This is like actually the one question where you need to use empiricism, I think. Or you probably don't need to. Probably the people that like the super geniuses that actually like proved it and they like knew all these facts, but like I feel like for 3,000 people, like the vast majority of these people must have just like empirically been like, oh well, in practice it's less bad, and like I can't prove it, but I just kind of assume it's the case. For example, this would count every x. You could only count sorted x's. You could only count sorted x's. Oh, you're saying you just optimize so that like you don't try every single thing. You like are a little bit smart about your backtracking. Yeah. Okay. That makes sense. Okay, well, what's the way to sort them? What's the way to not use 11 in multiple spaces? I mean, I guess first off, this doesn't even work, so I should get this to work. This is just a bunch of ones. Okay. If n%z. Oh, it's because I was in the middle of translating this from this. From like prime factors to just regular factors. Alright, well, I'll look at this later. $21.36. Is that this one? Yeah. Jesus. Excuse me. What is this, at coder submissions? No, I don't want that. Yeah, holy shit, dude. I don't know what happened there. What's the lesson to be learned there? I guess one immediate lesson is n to the 1/3 was a relevant time complexity. I didn't take that into consideration. I think another, if I'm not just like complaining, I think a legitimate other lesson was 2e8 was a time complexity that I kind of reached in other ways. I had this whole like DP state space where it was like something like, I think it was almost exactly actually the same. It was like n times 64 times 5 times 6, I want to say, something like that. Yeah. This was a state space I reached, and then I threw it out because I was like, this seems way too high. Yeah. So I guess I should have gone with this one too. Maybe that would have passed. Although it probably wouldn't have, because actually, if I'm trying to not complain, like I think the real thing was, yeah, I think the real thing was like if you sort it, it's not 2e8 anymore. It's like 2e6 or something, 1e6. That would have, I think that would have like saved me if I had realized that. 10 to the 5/3. A better upper bound. Is it really the number of its divisors of n choose 5? Is that right? Oh yeah, 10 to the 5th choose 5. No, that doesn't sound right. You can choose the same number of divisors multiple times. I think legitimately the lesson there is like, and I feel like this comes up a lot with specifically backtracking. It's just like, I guess just do the like poorly thought out brute force thing. And a lot of the time, like proving that like why that works is way, way harder than proving that it works by it working. So just do that. Just like submit it and it works, and then like don't think that hard about it. Because when you're explaining this, I'm like, oh yeah, okay, that makes sense. But it feels like it's a that makes sense as if you're like explaining some grandmaster problem, you know, like. But then in practice, it's like so simple. I'm like, yeah, I do see how many people thought of that. Like, if I'm really trying to emulate what's it like to be a person who got that answer right, it's like, just they probably the vast majority of people didn't think about it. But I think that's copium. I'm not gonna keep going on that one. I think the explanation you're giving is insightful. Okay, in the dream. Two football teams, 2 halves. The first half and the second half, at the beginning of the match, both teams have scored 0. No team will score 3 consecutive goals in the same half. The score at the end of the first half was A to B, where A is the score and B is the score. I see. Well, any score is possible between someone having double the score of the other person plus 2 or plus 1, I think. And I think you just kind of check, is that possible for these? And then you just take the difference here so that you're like, okay, just look at the second half. So for A to B, you would say 0, 0, 0, 0, 0, x, 0, 0, x, 0, 0, x, 0, 0. So you're saying at any given moment, this person is going to have double plus 2. That's the most they can possibly have. So check that. And then in the second half, you just do the exact same thing, but you subtract it. Okay. A, B, C, and D. If not, check A and B. Bool res is check A and B and check C minus A, D minus B. Print no yes at res. If A is less than B, swap A and B. Return A is less than or equal to B times 2 plus 2. I think that should be good. Yes, 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 no, no, yes, no, no, yes, yes, yes. Yes, 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 no, no, yes, no, no, yes, yes, yes. Like the bit set, binary string s of length n, integer k, wants to construct a permutation of length n so that for each number where s at I equals 1, I see, the following holds. For every interval with length at least k, if it covers position I, then the maximum element is not that element. Quick A, yeah. So okay, so it's saying, is there such a, okay, no, it is kind of confusing. Is there such a permutation that if we have like random numbers here, and then some of them are selected, is there such a permutation where for every L and R in this range K, it sounds like we're given K. Yeah, this is not the maximum. So find a better upper bound. Combination 10 to the 5/3 plus 4 and 5 with stars and bars giving 2e6. Goddamn. Okay. Yeah, I'll think on that one. I think it is a weakness of mine that I'm someone who like has to really deeply understand the ins and outs of something before I like take action a lot of the time. Not always, but especially with like Leetcode contests. So I think what it means is there just must be an element. There has to be two elements on either side of it. If you get what's the next greatest element on this side and what's the next greatest element on this side, or the empty spot, I guess, then R minus L needs to be less than K. Right, if K was 3, this minus this is 2. That's the final thing that would work. No, it needs to be less than or equal to K. So if you said you had like a 5 here and a 6 here or something, I don't know, and this was 4 and 3. There. Then you would say, okay, well 5 is the first thing greater on this side, 6 is the first thing greater on this side. If K is the number of divisors, you have K minus 1 steps to make, and however, oh, okay, this is still about the Leetcode one. D1, D2 up to DK, and you choose to advance to the next divisor or to take the divisor. Okay. I see what you're saying. That's why it's choose 5, because each bar is right there, you took it, and then now you're at the next divisor. Yeah, and then, okay, I see. And then plus 4 because you could choose 1 as a divisor like 5 times. Or 4 times because K can't, or because N can't be 1. And that would only account for any non-decreasing sequence of divisors. We just want those that have a product of N. Yeah. Okay. That's a good explanation for the time complexity. Okay, so each element needs to, if there's a 1 there, have an element to the left and to the right of it that's within a certain distance. Okay, and also I'm constructing it. So this kind of makes me think, is there an easy way to just like immediately tell? If it's 0, nothing needs to be greater than it. Note that there are no such constraints on indices with S sub I equals 0. Okay, that actually seems kind of important to note. Yeah, that makes me think you could kind of just do the exact same thing no matter what. You just treat it as like every single index is the same. So what would that be? That would be... No, that doesn't work. Because if S sub I is 1 for everything... No, that could work. Is there a limitation on K? For each interval whose length is at least K, then the maximum element is not p sub I. So if k is less than or equal to 2, immediately return. Wait, why is there a 2 here? Oh, okay, no. Yeah, okay. If k is less than 3, then you're done. No, that's not true. That's not true at all, actually. Okay, k could be 1, though. No, I think I'm rereading. I think I'm reading this wrong. This isn't at most k. This is at least k. For each interval whose length is at least k, so it's not saying at most k, it's saying at least k. Well, you could always just put the maximum at either end. And then if that doesn't work, then like you're shit out of luck. Yeah, I think you could say like, find the two indices. Let's say like this is a 1, this is a 1, this is a 1, and this is a 1. You could say find the two indices that are the furthest to the left and the right. Assign those to be the top two elements. The furthest to the left and the right that aren't marked. Okay, wait, I'm confused by this terminology. I see, for every interval. It's not p sub I. No, yeah, I think my initial kind of read was correct, actually. Oh, thank you, Phase Becky. Once again. Yeah, so there has to be two elements within K of each other. So you would say take, okay, Yeah, my initial thought was correct. Take the first thing greater, take the first thing greater. I don't see any world where you wouldn't immediately assign all of the numbers that aren't 1 to be large. You just immediately assign these. And then maybe you could BFS out. Yeah, what if you just BFS'd out? What if like all this is unnecessary? Yeah. You just BFS, right? If k is 1, you return false, because then each number will have to look at just itself and be not the maximum, which is impossible. So then you get like big number, less big, less big, less, less, less. And as long as there's a number next to you, it doesn't really matter what k is. No, that's not true. Yeah, that's not true. So for 0, 0, it doesn't really matter what you do. 4, 3. It said put a 4 here. Put a 3 there, and then it doesn't matter. This is not possible. Yeah, because it would have to be descending on either side. This is possible. What if you disperse to each k? You said every k minus 1 elements disperse in either direction. So for example, if k equals 3, you'd say, okay, 6 goes here. 5 goes there. 4 goes there. And then the rest of them don't really matter. No. Okay, maybe you greedily go through. You say assign all the largest numbers, and then it's just an ordering within the numbers that are unassigned. Is there ever any world where you even use the marked indices? What if you have like k equals 5? So you could say 1, 2, 3, 4, 5, 6, 7, 8. Yeah, no matter what here, anything you put here has to be the largest thing in its realm. So anytime you ever have a number of ones that's above k, or like 2 times k minus 1, something like that, it like necessarily won't work. It doesn't matter where you put the 7. You would need to say this is at most k minus 1. Okay. If r minus l equals k, okay. R plus 1, so you'd go, you'd say right here, L is 0, 0, 1, 2, 3, 4. 4 plus 1 minus 0 is 5. Right here, you know it's immediately impossible because this could be the largest element. Okay, perfect. Yes, yes, no, no, yes, yes. Two 1098765413. Yeah, that looks good. Okay. There's some deduction. You want to say what's the kth element back? I think that's not that bad. Have you done B? Yeah, I just did it. DP at 0. Prev is going to go there. We get N and then all the elements. Contest I got up to C after 30 minutes and then nothing. Let's see. Oops, I think I started this around here, maybe? $128. So yeah, it's been almost exactly 30 minutes. When I upsolved D and E, I was like, oh, I should have gotten that. Yeah. This one makes sense to me so far. A dot equals X. Prev at X dot push back I if prev at X dot size is greater than or equal to what am I doing here? I'm saying you can go from that index to this index. So I'll say B at prev at X at prev at X dot size minus X is equal to I plus 1. confusing, but so it's push back all the indices that have this value. If there's an element that's this value ago, go to that. Say, okay, be at that index is equal to I plus 1. And that index is the xth time ago that you've seen x. Okay. Fill n dp n plus 1, 0. Fill n b n plus 1, negative 1. Okay, go backwards and say dp at I is equal to max dp at I plus 1. Well, dp at I equals dp at I plus 1. If b at I doesn't equal negative 1, dp at I equals max dp at I dp at b at I plus a at I. One, two, four, 505 looks pretty good, I guess. Damn, that was like the fastest one. Okay, yeah, it looks like now I've been going for 30 minutes. For the champion, this is an interactive problem. Whoa. The team is hosting Robot Championship, and this time your robot is teleported to an infinite 2D plane with a Cartesian coordinate system in it. There are n anchor points on the plane, and the coordinates of the ith anchor point are xi, yi. These are given to your robot by the jury as soon as it's teleported onto the plane. However, your robot doesn't know its initial coordinates. In one move, assuming its coordinates are a comma b, you can choose an integer k and do one of the following operations. Move k units. After each move, the jury... That's very weird. You might need multiple moves to get to xi, yi. Will give the minimum Manhattan distance between the current coordinates of your robot and any anchor point. To win the prize, you must prove that your robot has high IQ. You must write a program for your robot to find its initial coordinates in no more than 10 moves. Wow, okay. Ten is no joke. That's like not even log k. Well, maybe you just say like 1, 2, 3, 4, 5, 6, 7, 8. You just like move in any direction. And I feel like if you moved large enough, right? Like if you moved a long enough distance, I think you could show, no, you couldn't show that. If you started at exactly 0, 0, and there was like 8 points that were all at like, or 4 points that were all at like the corners, you could still figure that out in like 8 moves, I think. Yeah, it's kind of tricky because I think you can show like if this is the Cartesian plane and you're here and there's like these spots, you can show like in one of these directions you'll go, well, no, it's not even this actually. And that's like my point. It's that this is only half of it. So you can prove with one of these. No, this is the wrong one. You'll be like out of bounds, and then you can use that. And then you could use two more to be like, I guess like, is this the out of bounds direction and is that the out of bounds direction? You could do something like that. Because you could say, move just like this -1. And if you got closer, then you know, no, you don't know that necessarily. Because you could say like, move this -1. But if there was a point like here and a point here, then you wouldn't know that you went out of bounds. So how can you validate like which direction you're going out of bounds in? I always forget to use that. Because if you knew that you were out of bounds, it's not Euclidean distance. Yeah, it's Manhattan distance. Manhattan distance is the minimum. You still wouldn't know though. Like there's still a world where like, I don't know. Wait, now Manhattan distance is the maximum, right? What if you just didn't go back? What if you just said like, move? Okay, yeah. What if you said move this way once? Move this way again. Move this way again. And now you know, no matter what, that the furthest point in the positive x direction is going to be that much behind you. So then you have that, and then you could move backwards. So 1, 2, 3, now you're at 6. And then, yeah, and then you go 1, 2, 3 up this way. And then you know the furthest northernmost point must have that. That means you have to use a long, but that's fine. We got n, and then we got xi, yi. My phone's about to die. I could just say get the maximum x and y. Oops. Question mark up. Okay. Exclamation point XY. So 3 times you're going to move left. No. Up and to the right. So question mark, right. X and Y, so res at 0 is equal to this is the distance. So you're going to get some distance that's possibly negative. You're going to get that. So you're going to say it's going to be the maximum x value you've gone 3 3 billion away from the center. So something minus 3 billion. If you just said it was this minus 3 billion. I think, isn't it just these two together? It's x plus z minus 3 billion. Okay, and then you go back. And then you go up. And then this is y plus c minus 3 billion. Okay. I don't really have any way to test this. I think I kind of want to double check. Whoops. Why would it not be x plus z minus 3 billion? That means if x plus z was exactly 3 billion somehow, which is possible, that would mean that you are at exactly x is 0. Because you'd say, okay, well, this thing was like 2 billion ago, and that's 2 billion out. Yeah. Doesn't really mean anything to run that. Actually, it does. That's really useful. In what world did it ever set that to be negative infinity? It set that to be negative infinity probably because it read n as 0 for this test case. Because this is just like nonsense. And then it said, okay, x and y are negative infinity. All right, well, we'll see what it comes up with. Oops, you found incorrect coordinates. Well, the correct coordinates are 199. That probably means I like said res at 0 instead of res at 1 or something. Yeah, probably right here. Well, that's kind of weird. Res at 1 is equal to that. Okay, well, see if this is any better. I don't know why I would add them though. Yeah. 199, 199. Okay, go right 3 times. Go left 3 times. Go up 3 times. Oh no, because the Manhattan distance is like the sum, not the maximum. I'm thinking of something else. I'm thinking of like king's move and chess distance. The maximum is Chebyshev or norm infinite. Man, that's a dumb oversight. Okay, but I don't think all hope is lost. Then don't I just have like 2 knowns and 2 unknowns? I'm like, I know for a fact it was looking at this point, and I know for a fact it was looking at whatever point is like here. So I think I can just take that out in a certain way. Because like true x and y, x is equal to z0, this, plus x0, this is the max x, minus 3e9. But then it's not quite, because it has one more thing. Minus y0 minus y. Right? Like this discrepancy right here, that y value is going to make the difference there. And so hopefully we can like be smart about it. Okay, and then y is equal to z1 plus y1 minus 3e9 minus x0 minus x. So then maybe I can just plug them in. So x is equal to z0 plus x0 minus y0 minus this whole thing. So minus z1 minus y1 plus 3e9 minus the absolute difference of x0 minus x. But now I have kind of a conundrum because I have to like get the x's all on one side, but it's not that simple because they're wrapped in 2 absolute values. I mean, maybe I don't need to go backwards. Like maybe all I do is I say, okay, those are the 2 points I care about. when I get 1, 2, 3, I know I'm looking at this point. And then if I said one, two, three, I know exactly what point I'm going to be looking at. I don't think this is enough information yet, but the point I'm looking at is going to be whatever point has the highest sum of coordinates. So I can say the sum of my coordinates minus the sum of those coordinates, minus 3 billion, minus 3 billion. I can tell exactly what the sum of my coordinates are. Okay, and then I think you can use X. Then you go back to here. Because you say X plus Y equals exactly this thing. That minus this known point is equal to the sum of coordinates down here. I think if you also said like go down, you have 2 extra directions, or 4 extra directions you could do. So if you said go down, go back up, down here, you know that you're going to be looking at this point. I don't think there's any way around it. And then you would say here, that's going to be the point with the furthest X minus Y. And then you can calculate X minus Y. Okay, I bet that's what it is. So go out, go up. Pair MSF1 is that, MSF2 is that, although I really want this to be negative infinity, negative infinity, negative infinity, infinity. This is X minus Y, X plus Y, X1 plus, these can just be X and Y now. X plus Y is greater than MSF1, I don't even think you need that. I think you can literally just say like, this is just the biggest X plus Y and biggest X minus Y. D1 and D2, so go right. Go down by 2. Do you even need to go right by 3? I think you just go right by 2 and up by 2. But whatever, I have extra to work with, so. Okay, so go all the way right, go down by 2. Now you have D1, go up by 5, now you have D2. It's very confusing. D1 is going to be positive, D2 is going to be negative. Okay, I gotta go to the bathroom. Okay. So this is the largest x minus y value. You know that your x minus y value is 500,000, no, 5 billion above what it should be. So x minus y is going to be MSF2 plus D2 minus that. But this one's going to be 600 or 6 billion. y is equal to z1 minus x. So therefore x minus z1 plus x is equal to z2. X equals z2 plus z1 over 2. Does that track? That means that their parity has to be the same. So x plus y and x minus y have to have the same parity. Yeah, that checks out. Okay, and y is z1 minus x. For a while I used to not do that, but I'm back on my bullshit. I kind of just got to YOLO it. I don't know. I don't really know. I can't really think of any way to like do it any differently. You don't even need the parentheses with that. That's the good thing. That's a big reason why I don't use it, because the order of operations seems really weird. I wish I could test it differently than this. Shit. I left these in. Two, -3, -1, 0. So it seems close. Right, down, up. So after you've gone right 3 times, down twice, you're here. Up 5 times. Okay, I think the problem is this is actually a 5. I don't know. I don't think that matters. Or at least it doesn't seem to reflect that here. Oh, that's good to know. I didn't know that. But I think it should be a 5, right? Because you move to the right 3, down 2, up 5. So you're really to the right 3, up. No, you're to the right 3, up 3. That was right. So I feel like I have to just like I'm in an interview. I have to like walk through this. So there's some point we're at. Let's say this is like 0. Let's say this is like 2, 4, and -1, 5, -1. Okay, so we go way out here, way down, way up. For these 2 points, you're going to get something where this minus 5, -1 is going to be, and let's say we're at point maybe 0, -1, something like that. Or let's say -1, -1. So here you would be at that times 5. So let's see, 99, 98, 97, 96, 95. Yeah. Yeah, you'd be here. This is your x minus y. Equals that minus 6. So it's equal to I think I'm missing one, 1, 2. Yeah. Would be this. Okay. X plus y. No, wait, this isn't really -1, -1. I'm going to say this is -1, 1. That's what this math would be. So then for x plus y, that cancels out. So it'd be 6. That minus 6 equals 5. That. So if x plus y is that, x minus y is that, then these two added together is going to be 2 times x. So 5, 1, 2, 3, 4, 5, 6, 7, 8 plus that over 2, but I'm immediately seeing that there's a 9 in here, which messes everything up. So where did that 9 come from? That 9 came from incorrect math here. This wouldn't be 4999995. I think this would be 49990 because no, that's not even right. It'd be 49998. Because x minus y is -2. So you're 5 billion out minus 2, minus 6 from this. Equals what was that, 4? That divided by 2. Well, that doesn't really make any sense. Oh, because this isn't... I need to subtract a huge number from this. Because this is the distance. So it'd be the distance This is the distance plus 6 minus this again. which should just be 0. So x plus y is 0 is what that should equate to, which is fine. And then this should say x minus y is equal to that minus 6 is the distance from this to that plus 6 minus that is equal to -2. Yeah. And then it would say 0 plus -2 over 2 equals -1. 0 minus -1 equals 1. Yeah, okay. So that logic, I feel like I just proved to myself that that logic is sound. All that means to me is there's like probably a misplaced something somewhere. Y is x plus y minus x, that makes sense. X plus y is MSF1 plus distance 1 minus that. Yeah. Ah, MSF2 x minus y. That's probably why. There we go. Okay. For an undirected connected graph of n vertices, where an ith vertex has a weight of vi, we define the value of a simple path as the, it looks like XOR value of all of them. Call the graph balanced if and only if something. Number of ways to assign weights to achieve the goal. Already candidate master performance. Well, that's good to hear. Makes up for that atrocious Leetcode contest. That was like god awful. One less than, okay. It's balanced if for every 2 distinct nodes, all simple paths from P to Q have the same value. Interesting, okay. The value of a simple path. Aqua wave. It's giving you an undirected connected graph of n vertices and m edges. The ith vertex in the graph has a weight of a sub I. However, some of the weights are missing, represented by -1. Wants to assign an integer weight between 0 and v minus 1 to each vertex with a sub I is equal to -1, so the graph will be balanced. Interesting. Well, I guess something to notice is like, if you ever had like a bridge, there's like a bunch of stuff over here, all leads here. You can just assign any of these two to be like any v. Between 0 and v minus 1. Are we given v? Yeah. Yeah. So you could just say like multiply that by v. Immediately these two could be, they have to, in fact they actually have to be the same. And then the other scenario is if you had some situation where right here all of these were different than all of these, then you don't have a 0 setup. You have a, there's some exact XOR value here that works. And then it would still be any v. Because I think for any, for any element, how many pairs of elements XOR to be that? Because if you could get that, you could say like this edge, anything that transfers along this has to be a given value. And I think the moment you have a cycle, if it's not a bridge, I don't think there's anything you can do, but that's like a theory. So if you have some like, this is Z1, this is Z2, x equals Z1, XOR Z2. So you need to have any two elements that will XOR to be X. So that's X and 0, X XOR 1 and 1, X XOR 2 and 2. It could just be any V elements, right? Times 2. Because this time around, you could swap it. I'm guessing it's like number of distinct. Well, it doesn't really, it's number of distinct anyway. The reason for this is because okay, so then what if you had not a bridge? What if an edge is like not a bridge? What happens then? Because if you could prove that this has to be exactly one value, then I think you're kind of good to go. So let's say this. What if all of these could be anything? Like none of these are assigned already. I think you can kind of prove they all have to be the same, right? In fact, I actually wonder if even this is true here. Because in what world every single path, oh, they all have to have the same value. Not necessarily 0, although 0 plays into it. Well, I think you can immediately prove they all have to be 0, though. And I think I actually just like went off that assumption because like I don't think if you had a 3 and a 2, it doesn't matter what you put here. And it doesn't matter if it's a bridge or not a bridge. You would always have a different value when you went to this path versus to this path. So I think necessarily everything has to have an XOR value of 0. Which means also, doesn't that mean that every single thing has to have a... Every single connected component has to be the same value? No, not necessarily. One, two, one, three, two, four, two, five. So this is a tree. A simple path. Is any path starting at C going to D such that there's an edge and no repeated vertices? One, two, one, three, two, four, two, five. 1, 2, 3, 4, 5. So it was 1, 2, 3, 4. I think it was that. Yeah. It's 1E9, something like that. Yeah. So, and then all of these are question marks. So why is this not 0? Why is the possibility not 0? Because no matter what you put here, every simple path has the same value. I mean, these have to be the same. Because if this was like a 5 and this was a 4, then any path that goes through here is going to be a 5, and then it's going to be a 4. Okay. I think Codeforces explains that last example. In this case, the graph is a tree. So there's only one simple path between any two vertices. Thus, we can assign an arbitrary value between 0 and v minus 1 to each a sub I. 1, 2, 3, 4, 5. There's only one simple path between any two vertices. Oh, from P to Q. It's not... it's saying for each P and Q. Okay. It's not saying all simple paths in general, because I was like, I think then you could just prove everything has to be 0. Okay. Okay, back to the bridge thing then. The bridge thing made sense. So I think right here you're saying you can change this by anything, but it doesn't matter. But the moment you have this, like I think this has to be... If there's a cycle, they all have to be the same. I appreciate that, Solaris. I was barking down the wrong path, I think. Because if you have a 3 and a 2 right here, it doesn't matter what this is. It has two ways to get there. One of them includes a 3 and one of them doesn't. Okay, but what if it's a little more complicated? I'm so weary of Codeforces examples because they love to do the like, Bob and Alice are playing a game, and then they're like, in their example, they do things that are like so incorrect, it almost feels like it's against the rules to do. They're like, for the very second move, they move their king forward 1, and it like, I've found it like, it's better to tune it out than anything. True, that's only for the game theory ones. Okay, so if you had 3 and 2, there's a certain symmetry here, right? Where you could say, no matter what, you go through a 3 and a 2. No matter what, you go through a 2 and a 3. So actually, it's not that every element in the same cycle has to have the same value. But it's got to be close to that. Isn't it every cycle has to have an even frequency of values? Because like if you have a big cycle, and you say, okay, this is a 3. It doesn't matter if you put a 3 here or like here. For anything on this side, it's going to go through 2 3s to get there versus like 1 3 to get to everything that's inside of its range. Whereas the moment you have a third 3, I think you'd say, okay, well, there was a way to get here through 2 3s and a way to get here through 1 3. It still might not matter though, because you could have like, if this was a 1 and a 2 and everything else was zeros, this actually would still work. But maybe it wouldn't work because there would always be an element. If you had to cancel out the 3 with something that's not a 3, there would always be an element that messes with that. But for that matter, I think even 2 3s could screw you up. Because couldn't you say, for this to get there, it's different than that? Yeah, actually, for that matter, this example, that's not true. Because you could do that and you could do that. 2 XOR 3 is equal to 1. Whereas 2 XOR 3 XOR 2 XOR 3 is equal to 0. So actually, yeah. Is there any world where this works? I think if these were all zeros, right? Even if these were all zeros though, it still doesn't work because you could say Well, 0 XOR 3 is 3, as opposed to 0 XOR 0 XOR 2 XOR 3 is 1. So I think even in the case where you have a bunch of zeros, I'm going to guess that you can have at most a single element that's not 0. Because the moment that this element is not 0 right here, then you've created two paths to anything adjacent to it. One of them is going through something that's non-zero, one of them is going through something that's 0. So I think what this tells me is cycles can have at most one non-zero element, and for trees, nothing matters. And you can just assign anything to anything. So then I think it's going to become a matter of, is it connected? It's connected. So it's going to become a matter of, does 0, 0, 0, 3 work? I think so. I mean, maybe I should double check that, but because 3, no matter what, you're just going to have 3, right? Oh, no, it doesn't actually. Yeah, you're totally right. I appreciate that. Because of this 0 going to that 0. So you literally can't have anything that's not a 0. So anything that's not a bridge has to be zeros. And anything that is a bridge can potentially be not a 0. So I think what I'm going to do is I'm going to say find the bridges. Find vertices V where the order of V equals number of bridges to V. Everything else must be 0. Because the moment anything has any two paths to it, it has to be a 0. Because that means that there's a path to something else that involved it and didn't involve it, and therefore it itself must be 0. I'm going to try that out. NMV. I think I'm going to call this X, otherwise I'm going to go crazy. We got that. This could be 4. No, that's not right. There we go. What do you think of the problem so far? I like this one. This one's like very thought-provoking. I liked this one. I want to say I liked A. I mean, A was like a problem. I liked... What was going on with this one? Oh, B was good. B was like, when I think of a Codeforces problem that's like kind of a headache, I think of B. Yeah. I liked D too. I think D so far has been my favorite. Okay. For I0M, I'm going to guess that that's what's happening next. U and V. Did you like D? I'm guessing you asked that before I said that was my favorite. IIU, IIV, U minus minus, V minus minus, PDJU dot push back V, and ADJV dot push back U. Okay. I want the in degree and the number of bridges. So I think I'm just going to say B It's the number of bridges to a given thing. And then that problem that literally used Semisolaris, I'm going to pull that up. It was in R. Yeah, Rada and the Chamomile Valley. So I had a whole big thing here. Do you think Devon's source code is written with competitive programming templates and macros? I don't know. Wasn't Devon the like super scammy one? Where they like literally were just hiring people to code? Oh, yeah, I'm gonna have to keep track of the edges, aren't I? Ugh, God, what a headache. Some legendary Grandmaster is part of the team. Yeah, I'm also like, I don't know. People, like the real sharks out there that are like that good at it, I think that doesn't necessarily mean they're like, the things they're doing are generative. I feel like it's more likely that they know that what they're doing is not generative compared to like someone that like really believes in a like crypto bubble. But I feel like a lot of those people from what I've seen, like they kind of know that a lot of it is like a racket. Let's see. So this had a whole like Dijkstra's to it. So I'm going to ignore that. This dist at U. That's like nothing. I don't care about that. Sort path up again, path dot end. This was the thing I cared about. This DFS function. Yeah, I immediately was like, I'm not rewriting this. This is such a headache. Oh, man. I mean, I don't know. I can kind of go through it. Okay, edges is that. Oh, this is going to be really nice. I got to start doing this more often. I think I don't really want to directly copy paste this though. That's going to kind of, I feel like, fuck with me because there's going to be so many weird things that like don't matter. Let's say I got a path, I got a stack. This seems like it's purely just finding the original path, which I don't really care about. Link at I, scene at I, ID at I. What was the point of ID? DFS, ID at U. Oh, that's like the first time it's been seen. Okay, so this stack is pretty useless. It doesn't really matter. All I care about is this DFS function. Okay, we got that. Did I define t? I guess I defined t. I gotta get food after this. Did I ever call t equals 0? Yeah. Do I need the edge? I think I do need the edge. That kind of matters. If link at v is greater than id at u, yeah, okay. Doing Codeforces, yeah. We got that, but now 80J is vector pair int. Okay, so it says assign u to t. I don't think I really have to do this. I think seen at I is 0 is not relevant anymore. I think I could just say DFS 0, 0 DFS. Because I know it's connected. I don't really need to deal with that. Okay, ID is T, link is T++. Oh my god, dude, my downstairs neighbor is a yeller. If ID at V is -1, you haven't seen it, or else link at U is min link at U ID at V. Okay, that all looks good. So now I should have bridges as all the relevant edges. Did I make, okay, B, what did, I think B was supposed to represent like, yeah, I haven't used B yet. B is what I'm going to use to and I'm actually just going to call it ind for ind degrees. That's what I care about. I it equals y, edges at that, ind at u plus plus, ind at v plus plus. It's mod this. Okay, for I from 0 to m, if bridges at I equals 0 continue, u and v is edges at I, ind at u minus minus, ind at v minus minus. Okay, for I from 0 to n, this is where res actually comes into it. Mod is LL, right? Yeah. I have a few to catch you to. Okay, for I from 0 to n, if A at I doesn't equal -1, if ind at v ind at v is greater than 0, valid equals 0, break. It's ind at I. Or else, if it is, then you just continue, it doesn't matter. Else if ind at I is equal to 0, then it's entirely bridges. And if it's entirely bridges, then res times equals... Well, let me think about this. If it's entirely bridges, then this can just be anything. It doesn't matter. Res equals res times x percent mod. Or else it has to be 0. Okay. Four one nine zero, big number. Okay, well the big number's right. So what's happening in example 2? 1 2 1 3 1 4 2 5 3 5 4 5. 1 2 2 5. Entirely bridges is an equivalent of definition of a tree. Don't forget to draw the graphs. 1 2 2 5 1 3 3 5 1 4 4 5. So in my mind here, nothing is a bridge and it should return 0. Oh, it's okay. It's going to return 1 because it's not invalid. But it registered as invalid. Well, no, that makes sense. Damn. I think it's a little more complicated than that. Is it? If everything was a 2... If everything was a 2, you'd say 0... 2, 0. So everything could be exactly the same element. So everything could be the same. Is there any requirement other than that, or do they all just have to be the same? If you had this, you could say, okay, I can reach this in that, or that. So there has to be no odd length cycles. Which I guess makes sense if it's entirely even length cycles. Right? No, that's not true. Is it? Yeah, no, that's true. If you had this and then that, you could say, okay, 2 XOR 2 XOR 2 is 2, as opposed to 2 XOR 2, 2, 2, which is 0. So it needs to be entirely an even length cycle. how to do that, I completely forget. That it cannot be bar type. Oh, of course, yeah, it can't be by bar type. So, okay, there's one more step, which is to BFS through, assign a color to every element. If you ever come across the same element, then that entire component needs to be zeros, or else they just need to be the same element. What time is it? 3:24. Looks like I started at 1:30. So there's a chance I would get this within 2.5 hours. I'm gonna persist and let's see. This contest was 3 hours long. All right, well then whatever I get if I finish this is what I would have gotten, because I probably would have gotten hungry too halfway through if I actually took it. Okay, so I need a couple more things. I need, what's the color and does it have an odd length cycle? I saw too, it looks like 4 seconds, 512 megabytes, so it makes sense that I'm like adding all this random stuff. We got color and odd. So it's just for every single element, BFS through. Okay. That's where it's going to come in right here. For I from 0 to n, if odd at I doesn't equal -1, continue. You've already kind of covered that. Okay. Bool found equals false. Q equals while Q is not empty. TMP for auto X in Q. Well, these are nodes we're talking about. For U and Q, for auto V and J in 80J at U, if bridges at J equals 1, continue. If color at I is equal to, if color at V is equal to color at U, then you found an odd length cycle. Oops. While Q is not empty, VICMP for U in Q. It really doesn't matter. Stack is I. Auto V and J in AJU. Okay, if it's already odd, continue. Odd of V equals 1. Stack dot push back V. Okay, now everything's marked as having an odd or even length cycle. This was a little bit sloppy. Right here, if color at V is equal to color at U, found is true, break, or else color at V is equal to color at U, XOR 1. Do your colleagues know you do competitive programming? Are you talking to me or are you talking to Solaris? For me, it's like a 50-50 split, I guess. I talk about it with my friends. It's like an interest of mine. Like it's like a hobby. Like if I was really into like Magic the Gathering or something, you know? No job equals no colleagues. That's fair. Column V is -1. All right, I mean, that looks good. So then it goes through auto V is 1. Okay, and now, because of all that, I think right here, I want to use valid. I want to just say, like, look for the cycles and everything right there. Like, don't do it down here. Okay, if int I doesn't equal 0, then this doesn't matter. If a and I, that part red doesn't really matter either. Okay, if AI is -1, you can set it to whatever you want. Found, perfect, okay. If valid is not true, then print 0 return. So if found, this is the odd length cycle section. So I can say if AU is greater than 0, I think it can be set to 0, right? Yeah. If AU is greater than 0, valid equals 0, break. Simple enough. And then here I need something that's basically like, what's the baseline value? If A at U doesn't equal -1, if val equals -1, val equals AU, else if val doesn't equal AU, then you have two different things in the same cycle. If val doesn't equal AU, valid equals false, break. There's not even really any point to that. I can just say print 0, return. So set it to this if it's -1, or else if it's not this, return 0. This one, if anything isn't 0 or -1, you have to return. Uh-oh. If odd at v continue, or else odd at v equals 1, so it's probably not this while loop that's lasting forever. Well, queue's not empty. I don't think I ever say q equals TMP. I also don't... Yeah, it's okay to have a found break, because right here, I iterate through every element anyway. 4110. 1, 2, 3, 2, 3, 5, 5, 1. So there's a cycle. Oh no, this is the one that doesn't work. -1, -1, -1, 0, -1. So there's a single element that can be used, but mine is saying that it just works. I'm gonna say right here. God damn, there's so much code here. Okay, this should have the 1. Perfect. So now I'm just looking at that test case. Res equals 1. So this should come through. Perfect. So I think I kind of want to say like VI Okay, does anything have an in degree of 0? Okay, well, a bunch of stuff does. Why is n? Okay, n is 7. Oh, because I printed int, not test. Okay, they all have an in degree of 2. But it seems like one of them should have an in degree of 0, would be my guess. So 1, 2, 2, 3, 3, 4, 1, 4, 1, 5, 5, 6, 7, 6, 7, 5. So 5, 6, 6, 7, 7, 5. 1 and 5 are connected. So it's possibly that you don't necessarily need everything to be the same if there's an even. If there's no odd cycles, it's that for every connected component, like maybe if there's just an even number of those. So I think the graph is basically this. And we have 1 here and we have 5 here. And the problem is, like, if there's a 2 and a 2, I think if this is a 0 and this is a 0, maybe that works as well. Right? Wouldn't this work? No, this would, of course this wouldn't work. Right? Because you could say 0 XOR 2 or 0 XOR 2 XOR 0 XOR 2. And this wouldn't work. Okay, what if there's a single 0? I mean, if I'm just exhausting possibilities. That doesn't sound right, because then this could XOR with a 0 or XOR with a 2. So what's actually going on here? 1, 2, 3, 4, 5, 6, 7. So what it really is that's a 0, that's a 0. Ah, I see. It's that all of these are part of the same connected component, but all of them are completely unset. So I can bring this up here. Valid is 1, res is 1. I can say right here, if found, if not found, and val equals -1, res is equal to res times what was it, x % mod. But I'm going to clean this up a little bit. Where's the print coming in? Print 0, print 0, print 0, print test. That should fix that test case. 1619, shit. Okay, the problem, that's an interesting one. That almost makes me wonder if I don't even need this last part, because everything will always, like, there's not really any, I don't really care about bridges anymore. So that was all kind of wasted code, which is a little bit of a shame, but like, what happens if I just do that? Okay, well, the bridges thing was completely useless. I guess I can just do it with I mean, we'll see, but it seems like I can just do it with a BFS through every connected component. No, because I needed it to know which edges were bridges. That's like kind of important. 4190. Damn. What do you mean connected components? I guess I'm talking about like in the context of this connected components that are not going through a bridge. If you took all the bridges out, you're going to get a bunch of subgraphs. Expected 0, found 1. Okay, well, that's good. 39th number. So there were a bunch of numbers where the exact calculation was correct. And then it just expected a 0 but got a 1. So when would that happen? I think that means I need to like double check these. So this one is if you were looking at cycles, you found two different elements in the same cycle. You immediately return false. It's not possible. That seems fine. This one is if there's odd length cycles and any of them are non-negative. That seems fine. That one, if not valid, returns 0, not really relevant. 39th, can I track that down? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. Nope. Damn. When would this not work? There was a question in a Codeforces contest in August which used Cartesian trees. Is it possible that this found is fucking me up? That seems very possible, actually. Because if I find an odd length cycle, no, right here I'm saying, and then the moment you find any element that's not 0 or -1, return. If color U is equal to color V, I don't think I really use valid at all. Yeah. If found, stack push I while stack is not empty. If AU is greater than 0, return 0. Okay. If odd at V, continue. Well, I guess I never say odd at I equals 1. I don't think that should matter, but... I mean, I made a bunch of tiny little changes. I think semantically it's almost exactly the same, but it's worth trying again. Yeah. When would this not work? Expected 0, found 1. Could it be that break? That's saying if you find two elements of the same color, expected 0, found 1. If val is equal to -1, val is AAU. If AAU was 0, then everything else has to be zeros. Okay. What happens if it's a link? That's not really worth thinking about. I would be so surprised if this was like the wrong path. Let's see, so I set A int link scene color odd ID. Edges never gets, no, edges does get set. ADJ gets reset. This is the one question I haven't done in this contest because so few people solved it. Bridges. Do I ever reset bridges? I do. No, I think he means that one, vortism. Hello, TechCast. I'm debugging a really complicated problem. If val is equal to -1. It's going to be the smallest thing. What's this one? Information about the symbols written in cells given as n strings s1 through n, where the same symbol as the jth character s sub I is written in this cell at the ith row from the top and the jth column from the left. Okay. Makes sense. How many rectangular regions consisting of, in most case, cells have all cells containing a dot? Now, the editorials on Accoder are very confusing. Count the number of integer tuples LX, RX, LY, RY that satisfy the following conditions. If I were to guess, I would say that this kind of combines two things. Oftentimes what you see with these problems is it's like, uh-oh, there's a query, like you need to like there's kind of, if n is the number of cells in a grid, there's kind of like O of n squared different rectangles you can draw. But in reality, like you can say like, okay, well, like what's the height above this on this line? And you go line by line and you say like, how far above this can I see? And if you kind of take a prefix sum down, you can kind of aggregate things into heights, and then you kind of wind up a lot of the time like collapsing a two-dimensional problem into a one-dimensional problem. I have no idea if that's what the editorial says, but having not seen this before, that's what I would try. Especially knowing that like it's got something to do with the Cartesian tree. Consisting of at most k cells. That's interesting. Oh wait, does this have to do with the Cartesian tree? I don't know. I'm mostly just giving my brain a break from this other problem because I'm like, I cannot find this. If it's a bug, I can't find it. And if it's an error in my logic, I don't see where the problem is. Like, let's say you have like this. What's my logic again? My logic is find all the bridges. So all the edges that are connecting two different cycles. So like this edge, this node and this node can reach each other. And I know you know this, Solaris, but just like, oh, you're doing this problem. That's cool. So find all the bridges, of which there are in my current graph. This is not a node. This is like the number 0. There are 4, but I'm not even gonna have those. I'm just gonna have this. So there's one bridge, and then say, okay, for every connected component, if you took all the edges out that are bridges, you're gonna be left with some amount of connected components. And let's just say, for example, we have this. Let's bring this back. Like this is a bridge. Therefore, we have 3 connected components. That node itself, this, and this. And then we say, okay, for every connected component, if it has an odd length cycle, let's say like that, immediately all of these need to be 0. If they're not all 0, are you sure you collect those correctly? I mean, probably. I don't know. The fact that it's not getting like the numbers wrong, right? Like all these numbers are correct. That like sketches me out. That's like, seems like it's pretty good. But I guess actually because these are powers of X, it actually seems possible. Like these seem really specific, but in a way, there's only like 5 powers of X that there really could be. Is that true? No, that's not true. Because for every disconnected component, for every like separate connected component, it's like, you're going to have potentially many powers of X. So all this is saying is like, how many times did you include a power of X? So you can kind of collapse that down to like, how many times did you do that? Every single time where I can do it once or more, I seem to have done it the correct amount of times. So that tells me that like, it's probably a specific corner case with 1s versus 0s where I gave a 1 when I was supposed to give a 0. Did you forget a mod somewhere? Are you in a case with no bridges maybe? It's when you return the correct value. Probably not, because like test case 1 has bridges and non-bridges in it, and like this is all fine. So, but okay, find all the bridges, look at every connected component. If it has an odd cycle in it, then all of these need to be 0. If anything in here is like greater than 0, immediately return 0, because like this is not possible. If it has an even, if there's no odd length cycles within the component, then if anything is set to be anything, then it needs to be that, or else if it's set to nothing, then you can multiply your answer by res. Let's say like these are both -1, which they're not in example 4, but, or example 5. And that's the time we multiply res by x. So for example, here it would say there's no odd length cycles, and let's say this was assigned to -1. Therefore, you can assign this any value from 0 up to x minus 1. You should try and random graphs to see if you had those connected components correctly. I guess so. I mean, I don't know. For VI and ADJU, if this is the parent, continue. If it hasn't been discovered before, then DFS through that. Yeah, the bridges are probably good. Yeah, I'm looking at this and I'm like, this seems like a pretty robust, I forget what this algorithm's called, like Tarzan's cycle finding algorithm. It's not this, although it's very similar to that. How do you ensure you don't cross a bridge? Tarzan's bridge algorithm. Every time I ever reference ADJ, I keep track of what edge is used. And if that edge is a bridge, I ignore it when the time comes. The mental modeling required. Yeah, true. And yet, I can't do a Leetcode Q2. That seems fine. It's gotta be some like typo. There's gotta be a typo somewhere that I didn't realize. If found, the only case where I care is AU is greater than 0. If AU is not greater than 0 and you found an odd length cycle, then that means that you could set everything to 0, so you're fine. If val is exactly equal to -1, this is the one time you're saying everything in this connected component can be any number. They all have to be the same, but they can be any number because it's not an odd length cycle. I'm not doing something similar. Point clouds or nothing like this. Oh, I thought you meant you were currently doing this. I was like, whoa. Wait, why is there another DFS once you have check for bipartiteness? So I called DFS here. It is the only DFS, right? Like in the found section. Oh, down here. What is this? This is going through again and making sure that there's nothing above 0 is ultimately what it comes down to. There's a lot of fluff in this code. I think I really could just say like, if found and val is greater than 0. But like earlier I had a bunch of early breaks here and also the code below, like don't defense this one. I feel like I've come up with pretty much a solution, but there's some sort of debug. I hope I came up with a solution, but there's some sort of thing I'm like not seeing, some bug. What's the problem? I mean, because I deleted all these early breaks, my thought process was like, this was purely to find odd length cycles. And then once you found an odd length cycle, this will go through the full. You don't explore the vertex on the bridges so you don't collect the components correctly. What do you mean? Like, the number isn't the problem. You need to explore them but not extend them. You're saying like in a situation like a tree where like all of these are bridges. Because it does explore these, if that's what you're talking about. No, like if two triangles are connected. Yep. Yeah, that's it. Yep. That's a good catch. Very true. Okay. Damn, nice catch. So what that'll mean is, I think you're right, actually, to point out like all of this is unnecessary. I think I can literally say, okay, that is goodbye. And then I can just say if return. And then this is if you found an odd length cycle, if val is greater than 0. Because setting anything to odd, next time you're not going to find it. Bridge in the middle. I'm actually thinking this would cause a problem. I think if there's a bridge in the middle, if you had this, like, you're pretty much just like get rid of that and then resolve each of these independently, right? But I'm thinking if you have a vertex in the center, this will get marked as odd. Well, what will happen here? No, this should be fine. It'll say all of this is part of the same cycle. Right? Are you talking about this situation? Or are you talking about the one above it? You wouldn't see the problem with just one bridge, the ladder. You need multiple bridges? So what about this? So the vertex on the bridges are all part of some connected component. Yeah, but I don't see how, like, if this is odd, the only way this ever returns 1 is if all of these are 0. If any of these are not 0, it's going to return 0. But I think the way you see it, you don't assign the connected components correctly. So if this is odd, it's always going to return 0, right? So I think that's not relevant. The relevant case is, what if this is an even thing? Then I think I'm starting to see more what you're saying, where it's like, if these were all 2, let's say. No, I don't know. That seems right. You have no odd length cycles, so no matter how you get to any vertex, if you went the other way, that's the size of the connected component minus this path size, which is always going to have the same parity. Let's say you explore starting from any of the nodes in the square. What would the exploration do? Well, these would all need to be 0, right? So you would say, you're at, currently your XOR value is 0. You go here. This is a bridge. So like everything after this is kind of predetermined by that connected component. You go again, your XOR value is now 2. I think I'm still not really seeing what you're getting at. Because like if you have an even size connected component, then any path from any 2 nodes in there will always be an even number minus the length of that path to get back, like to have another path. So like the parity will always be the same. So therefore, if the numbers are the same, you'll always have the same. So you don't even explore that node, right? You don't even explore the nodes that are part of a bridge. Do you collect the... Are you saying like I'm not exploring like this node itself? Do you collect the connected component corresponding to the square? I think I do, right? I say like every single... Like you're traversing through every edge that isn't itself a bridge. So it would traverse through like this, and then not this. Yeah. No, yeah. I mean, you're right. Like if bridges at j equals 1, it's saying, is there a bridge at j? So you only go to any v. Oh. Dang, okay. I was almost thinking about the corner case of like, what if you had this? Because there's a world where Tarjan's algorithm considers this to be not a cycle. What does it mean bridges at j? It doesn't mean that j is part of some bridge. J is the index of the edge. So I say for auto v comma j and 80j at u, like u is the current node, v is the next, like the neighbor node, and then j is like the index of the edge through which it has to go. Yeah. But I'm curious about this case actually. This is one that's gonna matter. So let's see, I think it's nmx. So 5, 1, 2, 3, 4, 5, 6. Let's just say x is like 10. Okay. Let's say -1, -1, -1, -1, -1. Except this is 1. So I'm saying this node value is 1. Every other node value has yet to be set. Ideally, what it would do is it would say, this is all a connected component with odd length cycles. There's a world where for some reason, like Tarjan's algorithm that I have implemented here, like doesn't, it considers this like some sort of, I don't know. Like I feel like there's a way to look at it where you can call a bi-connected component like disconnected at a vertex or disconnected at a bridge. And I could see that being the source of some of the confusion. So I'm like, that's like the one lead I kind of feel like I have. I really though, like beyond that, I'm like, it feels like it's got to be a typo. Okay, so we got that. I think I actually want like this, because if it's an odd length cycle, it doesn't really matter. All right, I gotta go in a minute. But I'm gonna see this through and call this person back in like 10 minutes or like 5. So if you have 7 nodes, okay, 7 nodes, 8 edges. Ideally what should happen is it should say this is a connected component with an even length cycle. No, should it say that? I think actually I do want bridges in this form. I think that's where the problem is. I want to say not what are the bridge edges, but what are the bridge nodes. So what's the easiest way to do that? Articulation points. Okay, it seems really similar. Hey, Pat. I got busted up by that last Leetcode contest. I didn't even get Q2. Okay. I think this is it, though. I think this is it. So we just got to modify this bridge algorithm slightly. It's not the critical bridges. It's not like whatever's past there. it's not this, it's this. That's what I care about. But you got Q3. I did get Q3. Q2, I went off the deep end. So I feel like there's a really simple, just change this slightly. Yeah, yeah. And then here, it's not if bridges at j equals 1. It's like, I'm just going to say bridges at v equals 1. If bridges at I equals 0 continue. That doesn't really matter anymore. Great, okay. Okay, and then right here, so two connected triangles would mean two biconnected components. I think so, right? Because you'd say, as far as this is concerned, no, is that even true? I don't even think that's true. Right? I think that's, no, I'm going back on this. I think that's not true. Because like, if this was a 0 and this was a 0 and this was a 1, yeah, that's great that like any path through here can do whatever you want. But like you can just straight up be like, okay, well this path is 0 and this path is 1. Yeah. So I think I shouldn't second guess myself with that. I think that's wrong. Damn. I thought I was onto something there. All right, I'll comb through one more time to see if there's like some typo. So we got fill ADJ, fill in degrees, fill the color, fill odd, which I don't even use anymore. So let me get rid of some of the stuff I don't use. I feel like if you just clean it up a little bit, that might help. I use color, I use ID, I use link. I don't think I use scene at all. Yeah. So scene is out of there. I don't think I really use in degrees. That didn't really matter in the end. Link, ID, okay, all the bridges are 0. Int doesn't matter. This doesn't really matter anymore. Okay, now it should be at least a little bit clearer what's going on. So set these, set bridges at I, set all the values, create the edges. I don't even think edges matters anymore. So I'm just going to get rid of that. Okay, for the DFS, set the time of seeing node U at T. Set the link for U at T. For every neighboring node, if it's the parent, continue. If it hasn't been seen, explore it. Okay, set the link at U to be the min of link at U and link at V. If link at V is greater than ID at U, this is saying if the earliest point that you can find anything from V is after you've seen U, then you know that the edge from U to V is a bridge. Or else if you have already seen it, I just moved. I moved into a much more hippie-ish environment, I think. Okay, then it's minimum of link in U and ID at V. So that seems fine. If link at V is greater than ID at U, yeah, this can never happen in this else statement. So that's fine. Okay, DFS through, res is 1. Okay, if you've already explored it, continue. See if you've found an odd cycle. Build the queue. Set this color to be, the initial color to be 1. See if you've discovered a value. While the queue is not empty, go through the queue. If the current number you're looking at is set, record that. If you already have another non-zero number set, then return 0. If color v equals color u, found equals true. Is it a problem with like fill n and then bridges needs to go up to m? I feel like those get me sometimes. I don't think so though. Those look fine. Or else if color v is -1, you haven't explored it. So explore it, set the color to be the opposite to this one. Go to TMP. If you've found an odd length cycle and you also found an element greater than 0, return 0. Or else, if you didn't find any values, you can set them all to whatever you want. Yeah, I don't know. I really don't see the bug here. Where does it fail in the test cases? It fails low enough down that I can't see it. The 39th, like I can see what, I think I can see the 39th number here, which is supposed to be a 0, but it's a 1. But in the inputs, it only goes up to like 15. But I think I made a mistake you didn't make. Interesting. So the basic idea is if ever there's 2 paths through a node to another node, even that's a weird way to put it. If a node is ever part of a cycle, then this has to either be equal to 0 and all of them are equal to 0, or all of them are equal to some value and there's no odd cycles. Maybe we both fail on 39 because of the same reason. All right, I really gotta go now. I gotta call this person back. Which works out because I think I'm almost exactly at the mark of when this contest would have finished. So made it up to D. I'm really gonna look at where that typo was because that's pretty bad. All right. Thanks for watching. See you guys.